All right. So my name is Boris Bereshnikov. I'm a principal program manager in Microsoft Azure Compute team, and with me I have Grant.
Yeah, so I'm Grant Shipley. I'm a director of Openshift at Red Hat.
And before we kind of jump into the content and everything else, so I wanted to tell you about what we planned for today's session, and hopefully that fits your expectation of the session. And if it doesn't, I guess we won't get offended as of this point if you leave and find some other session.
I will actually get offended.
All right, so we have to keep the bar high anyway.
You have to stay.
All right. We'll start with the very, very basic understanding what is Openshift, what's the concept of the Openshift, and what it provides. And then we're going into look into more details on how to deploy that thing on Azure and what kind of services we can use and provide out of Openshift running on Azure. And then literally almost more than a half we're planning to spend on a demo. So it will be one long running demo of what you can do with Openshift with a variety of things it provides. Before we begin and before we dive into the session, so a little bit about ourselves. So as I mentioned, my name is Boris Bereshnikov. I'm in the Azure Compute Product Group. I'm primarily focusing on running, the way I put it, running non-Microsoft things on Microsoft Azure, so Linux and open source. And with many of other things, I'm working on the Red Hat partnership, so that's how it became possible here. Previously, I was in a data platform group working on the Azure SQL DB and SQL Server itself. So Grant.
Yeah, so I am Grant Shipley. I've been at Red Hat for about 12 years. If you ever asked me, even 5 years ago, if I would be at Microsoft Ignite on stage with a Microsoft employee, I probably would have laughed that was never going to happen, just because I have always been an open source guy. I've worked on the SUSE operating system, worked on Caldera's operating system a long time ago. Written a couple books on OpenShift, very active in the open source world. And before I joined the OpenShift team, I used to manage an IT group at Red Hat responsible for all of our web applications and sysadmins to deploy those out to production.
All right, and before we dive in the OpenShift itself, so one sort of reminder data point. So why is it possible that two sort of guys like Microsoft and Red Hat standing on one stage presenting things about Microsoft Azure and Red Hat product OpenShift? So in November of last year, you may know that we have signed a strategic partnership between Microsoft and Red Hat, which made a lot of things possible to be run and supported on Azure. Again, you can read a lot of details on a couple of links I'm providing on the deck. It's not the point of going into those individual squares. But OpenShift is just one of the products, and you can run a lot of things and be supported on Microsoft Azure today. So with that, let me sort of dive into very, very basics of the OpenShift and kind of go layer by layer deeper as what it is and what it provides. So one thing, if you are not a Red Hat person, it might be actually surprising hearing a lot of OpenShift names, at least it was for me when I started. So what is the OpenShift origin, and what is a Red Hat OpenShift? What's the difference between the two, and how they play together? So the reality of this is OpenShift origin is the upstream project of the Red Hat OpenShift, formerly called Red Hat Shift Enterprise, and now it's Red Hat OpenShift Container Platform. And the Red Hat OpenShift is a free open source version, which you can download and use. This is exactly what we're going to be using and demoing today. And Red Hat OpenShift series of products is a commercially supported product. Obviously, if you're running production or any kind of large-scale environment, you are running that on Red Hat OpenShift Container Platform. So of Red Hat OpenShift container platforms, there are a variety of choices there. So there are a couple of hosted environments. We're not going to be talking about them today, but I'm just going to mention because they show up in the documentation. It's OpenShift Online. It's the public multi-tenant service. And OpenShift Dedicated, it's the dedicated hosted service. And then the final choice is your choice of the infrastructure. So in today's case, we're going to be looking at the Microsoft Azure as such infrastructure, and if my clicker works. So there are a variety of things you can do. You can deploy as a single VM if you just want to learn about OpenShift itself. But today we'll be doing everything on the Microsoft Azure. So in terms of the business value that OpenShift provides, I'm going to pass it to Grant. And Grant, why don't you explain what we can do with OpenShift?
Okay, cool.
Why that matters? Yeah,
so if I step back just for a minute, I'm going to assume some of you have never even heard of OpenShift. But what it actually is it is a container application platform that we work on. It is essentially Docker and Kubernetes as the orchestration tier, and then some tools on top of that to make it accessible to developers and sysadmins. And as part of that, people also ask me, well, why do I even care about containers? And so we probably need to address that first. Containers are not going to solve your problems. Everyone thinks containers are the holy grail. It's going to solve all of your computing problems at your company. It's not. It's just a single piece of technology with a lot of benefits. in that you can deploy a container in dev and ship that same container through all of your environments. So you know that you're not going to have differences between the different environments. Once you validate something, it's going to work, right? And so that's generally why you start thinking about containers, but containers are very easy to get started with locally, but it becomes complex pretty quickly once you think about moving these to production, and we'll talk about that throughout the slides. When we were designing Openshift, we had some key design tenets in mind. The first one was we wanted it to be self-service. We didn't want developers, excuse me, to have to send a ticket to the operations team just to try out something new. Like maybe you're a .NET shop or a Java shop and you want to try out Node.js, and you submit a ticket to get a new virtual machine, and the operations guy get to it at some point. What we wanted to do was create a platform that the operations has full control over to define what runtimes and quotas, meaning CPU limits, disk space, memory, that you can use, and then that developers self-provision after that point. We wanted it to be multi-language. So a lot of people think of Red Hat as just a Linux company, or perhaps you think of us as a Java company with our JBoss products. But we wanted Openshift to be available for everything, so we support every language, every runtime, all the way down to Perl, PHP. We even support .NET, Java, whatever the case may be. We wanted developers to be able to automate a lot of their workflows, and that primarily comes through the source-to-image project. And we'll talk a little bit about that later, and we'll actually show it in the demos, but we firmly believe that developers want to take advantage of containers and operations want to take advantage of orchestration, but they don't want to have to deal with the complexities involved in that. So we don't want developers spending their day writing Docker files and running Docker builds. So we created an open source project called Source to Image that will allow you to interact with the platform through source code, meaning you provide your source code repository, and Openshift will build the Docker image on the fly and then deploy that out and run it. We also believe that applications are not developed in silos, and they're not developed by a single person. And so having groups and users and role-based access and permissions were critical to the product as well. And some of Red Hat's customers are the largest companies in the world, and so they care about standards-based. We don't want people to be locked in to Red Hat. We don't want people to be locked in to our container platform, and so we're using right now industry de facto standards, which are Docker containers and Kubernetes for orchestration. We're the second largest contributor to the Docker project, and we're the second largest contributor to the Kubernetes project outside of Google. And these same companies, they're not running 1 and 2 containers for an application. They're running perhaps hundreds or thousands of containers for the application. And a lot of people call that web scale. I actually hate that term. There's a very funny video about web scale that's referencing MongoDB. You should Google that and watch it. It's pretty hilarious. But the platform we need to design to run hundreds of thousands of containers, right? And to load balance those. And because we are Red Hat, what is most important to us is that this is open source. So everything we do on Openshift is actually in the upstream communities. We spend most of our time on Docker and Kubernetes, and then the rest of our time in the upstream OpenShift community called Origin. And then lastly, it needs to be enterprise grade, meaning if you're a Fortune 500 company, or any company really for that matter, and a security exploit occurs, we need to be able to patch your running containers and provide you 24/7 support, SLA, all of that stuff. And that's the primary difference between OpenShift Origin and container platform that Boris was talking about. So I want to go just a little bit deeper into the actual technology and what this actually looks like. So this is the full architecture diagram, and the battery just died. There it goes. It looks pretty complicated, right? There's a lot to take in there, but don't worry. I'm actually going to build this up from the bottom so you can understand how all of this fits together. At the very bottom of the stack is the infrastructure part. This is your operating system, your hardware. We really wanted OpenShift to be infrastructure agnostic. We don't really care where you run it. You can run it on bare metal servers. You can run it on virtual machines, whether that's VMware or Rev or whatever the case may be. You can run it on your own private cloud in your own data center. You can run it on a public cloud. We're running today on Microsoft Azure is what we're going to use today. You can even have a hybrid approach where some of your containers are running in your own private data center and some are running in the public cloud in Azure. The only thing we really care about is the operating system, because we require SE Linux for security to kind of lock these containers down. So if someone does an escalated exploit, they don't have much access to things. That's why we require SE Linux. And so we require RHEL, for example, Red Hat Enterprise Linux. Today we're using CentOS. We can use Fedora. We can use Atomic. But it just has to support SE Linux. And there's two actual components to Openshift that makes it up. The first one is what's on the screen. It's called a node. And the nodes are responsible for just running the applications or the containers. That's all they do. They're kind of stupid, really. They don't have much smarts about them. They're just running the nodes or the applications. And in this example,
I think the sensor's on this machine, so.
oh, is it? Is that why?
Yeah, just
Okay.
be close to that. So.
I'll stand over here. What we actually deploy on the nodes are called pods. How many people are familiar with Kubernetes? How many people have heard of a pod before? Okay, the majority of people haven't. A pod is a Kubernetes concept that is basically just metadata about a container and how that container should run. So you can think of a pod as holding one container, one Docker container. And that container actually comes from a Docker image. If you're not familiar with a Docker image, you can think of it as perhaps a virtual machine in a shut-off state. It just has all the required libraries and source code for your application, but you don't run, the image is never ran. What you do is you take that image and run it in a container. Does that make sense? Okay. The image is just what the container should look like. And then we deploy that in a pod. And what's interesting is most applications will actually be deployed in multiple pods if you scale up. So you may have 3 front ends, and those pods are orchestrated via the platform. And in this case, we have the same application across 3 pods on 3 different nodes. Okay? Does that make sense? Okay. The other part of Openshift, besides the nodes, is what's called the master. And the master is responsible for several things, but you can think of the master as like the control of the platform. It's the brains. That's where most of the stuff happens. The first thing that occurs on the master is the authentication and authorization. Who has access to access the environment and what can they do? And we'll get into that a little bit more in a second. The next one is the data store. And when I say data store, I primarily mean the etcd database, which most people haven't heard of. CoreOS developed it, and it's a distributed key value store that lives across all the data. But if I want to specify what my running application should look like, that's actually stored in that etcd database. And then if the reality doesn't ever match what's stored in the database, the platform picks it up and fixes it. And that's how that works. The next thing is the scheduler. The scheduler is probably the most important part of the platform. This is what solves the complexity of running Docker in production. The scheduler actually pulls the Docker image from the integrated Docker registry that we ship with Openshift, and then it determines where it's going to actually place those into the infrastructure. So let's say we have an application running. It would pull the Docker image from the registry, and then it would then decide based on some characteristics of the nodes where it should place these, and that could be capacity of the nodes. It's basically going to figure out the best place to run this specific application. And it's going to also allow you to set policies on where these things should go. For example, you may want, in the first node, in the top left corner, you may want your front end talking to your database on the same node. So you can do things like that. You may also have one node that has 128 gigs of memory, for example, and you want all your Java workloads on that node. So you can do placement policies like that. You can also set it up to where you have different nodes for different environments. You may have 10 nodes set aside for dev and 100 set aside for production. And so you can define with a policy where to actually place these things. But what's important to know is these containers on these nodes are not actually visible to the outside world. To make them visible to the outside world, we actually use a concept called a Kubernetes service. And a service is not like a programming service. It's not like a REST endpoint. It's literally like you can think of it like a load balancer internal to the cluster that just routes traffic between pods or between containers. So you can set it up that only my front end can talk to my database. No one else can see that database. No one else can talk to it. And that's via the services tier inside of Kubernetes. We also have a health and scaling functionality on the master node. And this is very important because you may want to scale up an application. We do support auto scaling based on CPU utilization, or you can program your own auto scaling algorithm. It's pretty easy to do. But we also check the health of each of these nodes, and if something happens to where one catches on fire, and I kid you not, this actually happened to me and Boris yesterday, I think. It didn't catch on fire, but we were working on the demo for this application. Suddenly, we were in a big room with all the speakers, and everyone started saying, the network's down. What happened? And they came over and diagnosed it, and me and Boris, I blame him, he blames me, actually kicked the power plug by accident out of the router for the room. And so that's never happened to me. I always make a joke about a janitor coming by and, in the data center and knocking things out. We literally shut down the network yesterday, so I'm sorry for that. But mistakes like this happen, or maybe a data center goes down. And so what Openshift does with our health is we check if any of the pods go down or if any of the nodes go down. And if it does, with our etcd data store, we know that the current running state doesn't match the desired state that's stored in the database. So the platform fixes that automatically. It takes a couple seconds. And if you guys remind me, I'll show you how that works today. But this node went down, so we take all those pods and move them to an entirely different node on the platform. So when you start talking about containers, a lot of people talk about cloud native and stateless applications. You've probably heard stateless, stateful, maybe mode 1, mode 2, sound familiar? One of the most important things that we were trying to accomplish with Openshift, and quite honestly is where we spent most of our development effort initially, was in the upstream project to allow persistent storage. And so that means if your container goes down and comes back up, you don't necessarily lose all of your data. If you're just doing straight containers with no persistent storage and you had a database deployed to a container, if you bring that container down and up, your data's gone. Sucks, right? And so it's very easy to do like host-mounted volumes if you're familiar with Docker, but how does that translate to the data center, right? And so we spent a lot of time getting NFS and Gluster and all of these network-attached storage working with the platform so you can mount these volumes into your containers, and if they go down and come back up, your data's there. You can mount the same volume across multiple pods so they all have access to the same data. So it's pretty cool stuff what we've been doing there. But the last piece really is how do you make all of this accessible to the outside world, to the internet, right? And so we had to create a routing layer that sits outside of the platform. And by default, we ship with H8 proxy, but we needed to make it pluggable so you could use F5 or whatever you're currently using, whether it's hardware or software, for your routing layer or your proxy or your load balancer, whatever you want to say there. That is completely pluggable. And then lastly, developers and admins need to interact with the platform. And that happens through the REST API. And so, we have a command line utility, we have an administrator utility, we have a web console, we have IDE plugins, we even have an IDE plugin for Visual Studio through Click to Cloud.
Click to Cloud, yes.
Click to
so
Cloud.
That's one of the partners that work with Microsoft too in Openshift. to create a plugin for the Visual Studio that allows you to control, basically to deploy the .NET application by pointing to the endpoint of the OpenShift cluster. So you can stay within Visual Studio, rebuild it, and deploy it right on the cluster.
Yep. And so what's important to know is that regardless if you're coming through Visual Studio or Eclipse or IntelliJ or the command line, it all goes through the same entry point, which is that REST API. They're all considered first-class citizens. No one has shortcuts. We're going to be using the web console today, but it's talking through the same API that the IDE would. There's absolutely no shortcuts to it. And then that goes into the master node. The differences in color here is to highlight, even though we spend a lot of work on Kubernetes, we've added a lot of stuff on top of Kubernetes to make this very easy to use. And so the orange boxes or squares or whatever, no, they're definitely not squares, are OpenShift specific things that haven't made it into the upstream Kubernetes project yet. We have no intention of keeping these things separate from Kubernetes. OpenShift is just always a little bit ahead of where Kubernetes will be in the future, just because we do a lot of our development on OpenShift and then push it upstream. And so Kubernetes has a concept of a namespace. We expanded on that and created a concept of a project to allow us to do role-based access and permissions among teams and things like that. If we dig a little bit deeper into the architecture of the platform, spacebar always works. Yes, it did. There's different concepts inside of the platform. Everything in blue are core Kubernetes concepts that are in the Kubernetes upstream project today. And all of the orange things are additional things that we've created. To me, the most exciting one is that source to image project in the top left-hand corner. And that's where we can take source code and build a Docker image and a deployed Docker container on the fly. We also have the integrated Docker registry, and we ship a software-defined network inside of the platform itself. And so I know that's a lot to take in. What I really want you to take away is OpenShift is a container platform that makes it easy for developers to take advantage of Docker and Kubernetes, which is the orchestration image, without having to know too much about those technologies. Okay?
So I'm going to talk about the deploying OpenShift on Azure. So all you have heard so far is actually, so once you get into OpenShift realm, you only talking to OpenShift. So how do you get one on Microsoft Azure? So that's what the next couple of slides are about. And then we'll do a demo of actual deployment on the Azure. So if we look at the diagram that kind of shows the layers of what the platform look like, so you will see that normally we provide the infrastructure services by either Azure Public Cloud or Azure Stack. And then we have concepts of VM or VM scale sets running on top of the infrastructure. That's typical for cloud provider. And then you can run Red Hat Enterprise Linux or SC Linux enabled distribution that we support as well. And OpenShift in this case, it fits just above that. So it interacts with the VM extensions. And I'll explain why that matters. We use VM custom script extension to deploy OpenShift. And it provides the effectively platform as a service layer to the end customer. So once you deploy it, once it's up and running, your applications interact with Red Hat OpenShift endpoints. They actually don't know which infrastructure you're running on. So there are other Microsoft Azure services which you can find a lot of similarities with. One of them is the Azure Container Service and the Service Fabric. So they serve slightly different purposes, slightly different ways how they interact and how you control how you manage it. For example, ACS exposes a couple other container orchestrators, Docker Swarm or Mesos DCOS. But if you start looking at those things and kind of comparing what Grant just explained to you, you will see a lot of things that are kind of coming similar. So they solve very, very similar problems. So if I double click on that Red Hat OpenShift block, what I see inside is that, again, just above the infrastructure platform, I'll see my container infrastructure that OpenShift maintains and the various things, various pieces of lifecycle automation and container management that OpenShift implements itself. So when we're going to be working with OpenShift cluster, which we're going into very, very shortly, so we're going to be deploying containers with the apps, and then those apps is what your end user is going to be consuming, but you're always interacting with the platform above that layer. So you, as I said, you won't even know that you're working, for example, with the Microsoft Azure as the backend. So that's one of the kind of strategic things that Microsoft has changed. I don't know if you noticed, but it's very, to me, this is actually amazing that we're doing this. We effectively letting you run platform as a service platform that allows you to move between different environments, including different clouds. So we believe that we're actually enabling you to do that choice and trust us as a platform to do so. One other thing is, so if you already have Red Hat workloads, obviously this whole scheme works with whatever variety of other things you might be using, be that Cloud Forms, Ansible deployment management, or anything like that. So again, this is just comes out of the box as you do it. Now, as we jump into the deployment, so I'm going to talk about those things, like what do you need to actually deploy a cluster? And you can try it out. So one thing I'll put a plug for is, so we have a lab tomorrow at 2 o'clock, and we have another session by Red Hat guys, Nicholas, who's in the room, to talk about OpenShift. So in the lab, you can actually try things out. But what you need is you can go to the so-called Azure Quick Start template. So it's aka.ms/OpenShift. And it uses custom script extension to configure the cluster and actually call Ansible deployment of the OpenShift cluster. And after that, Ansible deployment goes and completes the installation of the cluster, and you have the cluster up and running. We do use Azure Key Vault to store private SSH key. This is one prep step you need to do. We're going to be deploying OpenShift Origin over CentOS. So if you want to deploy actually OpenShift container platform, formerly OpenShift Enterprise, and you want to use Red Hat Enterprise Linux on that, so those things you need to have entitlements from Red Hat. It could be developer licenses, but make sure you kind of a little bit complicates the process because you need to register your machines with a particular entitlement to get OpenShift Enterprise in your machines. Again, we can talk about it later if you have questions about this. We're going to be using user password-based authentication. What Grant was showing, OpenShift supports the OpenAuth protocol, which is, for example, you can use Azure Active Directory to manage your user. You never have to add users, you just manage your Azure Active Directory. And we can show one of the clusters that does it. Default install of this uses zip.io, xip.io for app DNS. Some providers block that. So if you're not getting routes exposed and you do not have your custom domain registered to OpenShift cluster, check that your DNS actually letting those commands through. Again, this matters to help you build stuff and make sure stuff works. But from that, I guess I'm going to talk about, so what are we going to be actually deploying in terms of the Azure infrastructure? So we'll have a cluster, and we built 3 of those, so we'll deploy one right now. So we'll have one master and 2 nodes. So nodes are hidden behind the load balancer. So you have a public IP open on a couple of ports. That's where your applications will be exposing their services. In the master, what Grant was showing in the diagram as he was building up, that's the control plane of that cluster. So it opens port 22 to SSH in, 8443 to work with the REST API of OpenShift cluster. And that node actually talks to the nodes to deploy, to allocate pods and deploy the application themselves. So each one of those machines have a premium storage disk attached. That's where we store the Azure, where we store the registry, where all the containers are. And that's where you can have your persistent storage. Again, this kind of makes it more real in terms of what the cluster would do and what it works like. But if you want a simpler, cheaper version, you can make machines smaller, and you can kind of omit the data disks to run on the OS disk itself. Again, that's for proof of concept style of things. So one other thing you can do, you can spin that cluster up. The one that we're going to be doing, they cost around $1.50 an hour because we're using huge machines. We're using 8-core machines, 16 gig on each, with a premium 1 terabyte storage on each. So those are not cheap things in Azure. But you can start and stop to make it happen. So again, this is kind of the thing you should be aware of in terms of if you want to run it on any kind of trial subscription, make sure, be aware of the cost, because usually trial gives you about a couple $100 of credits. So with that, let me switch to my machine and show you what it takes to do the deployment. My machine went to sleep. All right, so as I mentioned, so aka.ms, that's where I would go, aka.ms OpenShift, and let me make it a little bigger so that you can actually see what happens when I type this. So when I type aka.ms.OpenShift, I land into Microsoft GitHub repo that hosts a variety of OpenShift templates, and we're opening the OpenShift template itself. So one of the technologies that we're using, the Azure Resource Manager, if you're not familiar with that, go read about it. But that's what the template effectively does. It combines number of services in a single package, in a single solution that becomes your OpenShift cluster. So to actually do the actual deployment, so what I'm going to do, I'm going to clone that repo, which I have done to a local machine, that creates a copy on my laptop so that I can actually do any kind of modification of the files. So after I've done that, so I'm going to use the Visual Studio Code. Actually, one of the funny things that we were noticing, so I am the Microsoft guy, right? So, and I'm using the Mac laptop to do the demos, and he's the Red Hat guy, and he came with the Windows machine. So that's the amazing piece of it.
I thought if I didn't show up with a Windows machine, they would kick me out. So
But it turns out to be we're kind of very different company. So this is the Visual Studio Code with that template open. Again, I'm going to zoom in to show that I'm in the Openshift origin rel folder. And there are a couple of things you need to change. So you need to look inside of the Azure deploy parameters files, and you need to find all of the change me things, and just those things you need to make sure you change to something meaningful. And this, for example, determines what the VM sizes are, what kind of flavor of the OS you're going to be deploying, CentOS or rel, and then whatever your unique parameters are. So I created a local file that has all of those values populated. And README on the page itself actually describes what every single parameter does and what's it's needed for. So one step that you will need to do before you start the deployments, you need to generate SSH key, and you need to put that private key. Come on. I'm not touching the machine. So you need to generate SSH key, and you need to put it in a key vault, and you need to enable that key vault for being accessed from the template. So I've done all of that, and I'm going to show you what the file looks like. So in this case, I'm using DS3 V2 machines. That's the 8-core, 16-gig machines. I'm using CentOS as a base OS. This is the unique IP. That's how my cluster is going to be known once it's deployed. So that's a prefix to the DNS name. It has to be globally unique within your, actually it has to be globally unique across the world because it's a DNS name. So picking something unique, in this case, I'm just using origin-master and putting a big number in it. That works. I'm going to be using two nodes, and this is my user and the password. Please don't destroy the clusters just yet, since you're seeing the password. And this is the public key that's used to log into the machines. Now, once you deploy the cluster, actually, you don't really need to log into the machines because you're going to be working with the Openshift REST point APIs. And this is the reference to my private key that's going to be used for the machines to connect between each other. Just a reference to the key vault. Now, the rest of the deployment is actually relatively easy. So you're going to go into a command line, and I'm using Azure CLI. So I'm just going to be doing Azure group create, and I'm going to name it Openshift resource group 5, and I'm going to place it in the East US 2 because I think that's probably the closest data center we can have with the minimized time. So once that group is created, it's simple operations, just the container for the deployment. So the rest of it is I'm just going to do Azure group deployment create, and the thing that I'm going to walk you through here. So I'm calling the OpenShift RG5 group. So that's the group I have. I'm giving a name to the deployment. It could be anything that's an acceptable name. And I'm referring to a local file. So there are a couple of options for the group deployments. You can refer directly to the OpenShift repo quick start template through the HTTP. And I'm referring to my local parameters file, right? So that's the thing that I need. That's where I specified all the parameters. Now, the reason I'm referring to the local file is actually, as we were debugging this with Grant, we realized that we're deploying older version of the OpenShift, and the last Thursday, the OpenShift 3.3 got released, and we needed to add this label into the deployment parameters to make sure that we're actually picking up latest and greatest. So after I hit enter on this, so what happens is this thing goes and starts deploying. So it takes parameters out of my local file. It takes the Azure deploy.json file that describes all of the cluster and configures the cluster in the way that's specified in the parameters. If you want to explore what those things are, if you want to help if you actually want to customize in any way or form, just look through those things. But conceptually, what you're doing is you using custom script extension to generate the config of the OpenShift cluster, and you calling that extension with a bunch of VMs that are defined in the template. So after that, it takes about anywhere from 20 to 30 minutes to actually all of the processes to complete. So VMs come up pretty fast, and then Ansible pulls the code from outside of the internet and deploys the rest of the cluster. So with that, we actually have a cluster. Hopefully, as we complete the session, we'll have that cluster up and running if I didn't mess up any configuration parameters. And why don't you show us a simple app?
OK. Let me switch to my awesome Windows machine. And you have to bear with me. I'm not a Windows user, so I hit wrong keys a lot of times. So.
And maybe one thing I'm going to show, sorry, Grant,
Yeah.
I have to show it on your machine. So I'm going to zoom it in for you. So one thing you can see in here at the top of the line, so remember that unique URL that I was talking about? So it was 2005 in my config file. So that's what it's going to be. That's what makes this cluster unique. This is the region I'm deploying to, East US2, and to the, origin master is my control plane. So if you hit the duplicate of somebody else's or your own, then the deployment will fail. Just be aware of that. That's all. And we're zooming out. All right.
And I'm sure Boris is tired of me this week because I've been asking him the whole time. We've been working together. I'm like, how do you delete a directory in Windows? It's just funny. So I'm going to log in here, and I'm going to log in as the Azure user.
So those are the credentials you've seen on screen. So that's exactly what he's using.
And if I typed them right, I'm going to be presented with my project overview. One of the screens is bad. That's okay. Look at a different one. So the first thing I'm going to do is actually create a project. And a project, if you remember from the slides, is just an organizational concept. So I'm going to call this project Guestbook, and then I'm going to start deploying containers in it. So a project can hold one or many applications. It just depends on how you want to organize things. So I'm going to call this Guestbook, and I'm going to click on Create. So now that I have a project created, the first thing that the platform wants me to do is actually deploy something, right? And so a lot of people have been working with Docker in the past, and they may have a Docker workflow already created. Now that one went out. And so we need the ability to just deploy a straight Docker image, right? So I'm going to deploy a Docker image from the public Docker Hub and see how that works. And so what's going to happen is it's going to pull an image down from Docker Hub. Kubernetes is going to do its magic and create some metadata around it, create a pod, and then deploy it. So I'm going to click on Deploy Image, and I'm going to deploy the famous Kubernetes Guestbook application. And the first thing you'll notice is that Openshift gives me a warning. It says, you know, hey, Joker, what are you doing? This Guestbook application runs as the root user. Are you sure you want to do this? Now, by default, Openshift disables the ability to run privileged containers. And unfortunately, 99% of all public containers runs as a privileged user. That's probably bad practice, right? We don't want to do that. We specifically don't want to run just arbitrary Docker images that we found on the internet, but I'm going to do it anyway. And so I am going to click on Create. It's going to contact Docker Hub, and it's going to download that Docker image, and then it's basically going to wrap it in a Kubernetes pod and run a Docker run command on it, and it's going to deploy it, and then it'll be available for me. So we'll give it just a second to finish here. There we go. It pulled an image down from Docker Hub and deployed it. Now, if you remember from the slides, this Docker image is not accessible to the outside internet because I have to add something to that routing tier. So that's what I'm going to do now is I'm going to create a route to make this container accessible to the outside world. And I can give it my own domain name if I want to, or I can use just the default one. If I wanted this application to be deployed underneath a host name, like maybe my company was Microsoft and this application was called app1, and I wanted it to be available at microsoft.com/app1, I would put a path here for it, and that's where it's going to be available. I am just going to click on Create and just use the default, and now I have a route that anyone in the world can hit and access this running container that we just pulled down from Docker Hub. And there it is. There's the Kubernetes Guestbook application. It's actually waiting for a database connection to Redis, but we're not actually going to deploy the database yet. We're going to do that a little bit later. We're going to be using MySQL a little bit later. But what I wanted to show you was just how easy it is to create a project and actually deploy existing Docker images if that's what you have. Now, what we're going to do next is I'm going to let Boris, I believe you developed an app, didn't you? It was a PHP app?
It's a PHP app, yes.
But he doesn't know Docker, unfortunately.
Yeah, so
and so
I'm clueless on that. So
he's going to show you how he would interact with the platform.
All right, so what I'm going to do, I'm going to show you the, so I have a GitHub repo. Just need to make sure I type GitHub correctly. That has an application that's a simple PHP application I found on the internet and learned when I was learning Openshift. And I created a very, very simple web page that all it does, and this is not the point of reading it, but it's just the web page, PHP web page with some code that acts as a database. So what I'm going to do, I'm going to go back to the web console, and you can see the guest book. So we using the same user, and we actually gave ourselves a higher level privilege for this demo. So we're seeing a lot of other projects as well. So I'm going to create a new project here, and let's call it PHP demo. And PHP demo just as description. We don't give it description. So I just created the wrapper, the project wrapper, where I'm going to be deploying my containers. And I'm going to go, because it's a PHP app, there's a so-called concept of the builder image. So builder image is something that it knows how to take source, compile it, and combine it with whatever other parameters are defined in that builder image, create a new Docker container, deploy it into the OpenShift registry that is local to my cluster, and spin up the app out of it. So that's exactly what I'm going to do. So I'm going to pick the latest PHP 5.6. I'm going to name it PHP 5.6 just for the lack of better word, and I'm going to point it to my GitHub repo. So remember, this is my OpenShift demo. So I'm going to go and grab a URL out of clone and download link from the web browser, and get back to my OpenShift web console and give a Git repository name in here. So after that, I can specify additional parameters, like I can use a different branch and things like that. So if you're familiar with Git, you know what those things are. I can also define the limits. So this app cannot consume more than a certain number of CPUs, memory, and so on and so forth. But for this time, just for the demo purpose, I'm just going to hit create. So a couple of things happened. So I just pointed my OpenShift cluster to my GitHub repo, and actually OpenShift is smart enough and says, I'm going to give you a webhook trigger. So webhook trigger is this complicated URL which I just copied of the UI, and it also gave me the link into my GitHub repo where I can set the config of this GitHub hook. So I'm just going to command click on this to open new tab, and this is the webhook for this particular repo. As you can notice, I'm on GitHub.com. And I need to confirm every time I do this. I need to confirm the password because this is a considered privileged information. And I'm going to paste that GitHub hook right in here. So what you can see in this GitHub hook is that it just refers back to the origin master. So it calls the API of OpenShift whenever there is a change in the GitHub repo. So, and you will see why that matters later. So I'm going to update the webhook pointing to the application. Let's get back to our web console and get to the overview. So what you will see in here is that while I was doing this, the build has completed. We'll see the builds a couple more times, and the pod is deployed. And because I was doing this through the UI, the route also got created because it's a source to build their image. And I'm using this zip.io. Again, zip.io is one of the things that cause people troubles. So what this is, so that you know, is zip.io is a free service that translates the URL that contains an IP in it just back to that IP. So it's like a cheap way of saying that whatever I have the IP for, just get my IP that IP back. It works when you don't have your own DNS name, but some providers definitely block that. So what happens in here is that I just created the application, and here we go. So OpenShift Hello Ignite 2016. Now what I'm immediately noticing is that I have 4 exclamation marks. That kind of looks crappy. So let's make it a little bit less exciting. Put 3 exclamation marks. So I'm going to start Visual Studio Code again, and I'm going to open the local clone of that project, so OpenShift demo project, and I'm going to open it on my local machine. So what that does, it goes and grabs a copy of my cloned repo on the machine, and I can see that same code in here. And I'm going to say, hey, let's leave only 3 exclamation marks in here, and I'm going to hit save. So Visual Studio Code integration with GitHub notices that I changed the file. So I need to submit that change to GitHub itself. And because I'm working on the local repo title correct, I'm committing that change to the local repo. And let me go back to the terminal window and illustrate that this change actually happened in here. So I'm in the folder that contains those things. And I'm just going to type git status. So what you see, the phrase you should notice in here, your branch is ahead by 1 commit of remote branch. So I made the change locally, but I haven't pushed that change into github.com. So the command to do this is git push, and I can give it -v to be verbose output. So the change happened, and let's see what happened with the application itself. So we're going to go back to our web console. And what you immediately see, there's a new line in here that says there's a build running, right? A new deployment will be created automatically as it completes. So I'm going to click on that build number 2. And what you see in here is that GitHub webhook got activated. So that the change so-and-so authored by me got picked up. So what happened here is, as I pushed my change to GitHub, GitHub made a call back into OpenShift and told it, hey, there's a new source. Go pick it up and build. Now, what you will see if I go back to my the application, right, and I have 4 exclamation mark, and let me make it a little bigger. So if I just hit refresh, 1 exclamation mark goes on. So this is source to image. This is where it works. I'm editing the source. And now, as Grant was pointing out, so those things are not working. We're not working alone. So, and I have no clue how to hook up a database. So, Grant, why don't you show me how to do things like that?
Yeah, sure. So, as always, Boris kind of takes things halfway there, and then needs me to come and finish it off. So let's do this. I'm going to go back to the home, and you created a project called PHP Demo. So I'm going to check this out on my machine. I'm going to pop it up, and I have the same site you do. And so now the first thing I want to do is actually connect this to a database. And so I'm going to look at the source code and see what he's doing here. And I see he's connecting to the database through these environment variables that defines the database username and password. So what I'm going to do is just add a MySQL database to our project. And so I'm just going to search for MySQL. I'm going to add this one. 512 megs is good enough for our demo. I'm going to call the connection username for demo purposes MySQL and leave the sample DB as the database name. So I have a username, password, and a database I can work with. I'm going to click on Create. Now, just like everything else on the platform, what it's actually doing is downloading this Docker image, and it's going to run it as a Kubernetes pod. And so I'm going to wait for that to finish, and we'll give it just a second here. And at any point in time, if you want to see what something's doing, you can just click on the View Log, and it will tell you what's going on. And right now, it's waiting for the pod to become ready. And while we're waiting for that, it's done now. I can actually group these two things together. So I want to marry my database to my PHP front end. So I'm going to click on Group Service, add MySQL, and the UI will update to let me know that these two things are working together. The last thing I need to do is add these environment variables that Boris is expecting in his deployment. So I'm going to go to my Applications and Deployments. I'm going to select PHP 5.6, click on Environment, and here I can add these environment variables. So the first one is MySQL Service username was MySQL, and MySQL Service password was MySQL, and lastly the database was MySQL Service database was sample DB, and I'm going to click on Save. And that I just changed the truth of that deployment. So what was in the data store no longer matches what was running in production. So OpenShift fixes that problem. It recognized that my current running pod didn't have those environment variables, so it's going to correct it by deploying a new one and adding those environment variables, and we're done. So let me check this, and now we can see the database is actually connecting. It looks like he's just tracking the IP and the date, and you
can hit a couple of refreshes just to see that this table gets populated.
You're very proud of your code, aren't you?
Of course. I mean,
I actually hate your code.
I got that far. Come on.
I don't like the title, so I'm going to change your title. All right. So what I'm going to do is I'm going to go to his repo here, and I'm going to fork this into my account. So if you're not familiar with Git, what a fork means is I'm just taking a copy of his source code and putting it in my account. And then I'm going to clone this code to my local machine. And I'm using PowerShell. I'm surprised you guys are not clapping that the Red Hat guy is using PowerShell. That's amazing, right? All right, so let me see what I got here. LS works in PowerShell. Awesome. OK, so I'm going to git clone his code that I forked. And I'm going to go into that directory. And I'm going to start Visual Studio Code. And I'm going to look at this index file. And let me make it a little bigger for you here. And here is his title. I hate people who use exclamation points like that. So I'm just going to say hello. And I'm going to save this. What Boris did, though, I don't actually like to do, which is trigger a new build every time I work on code. When I work on code, I iterate quickly. I want to change something and see it immediately. And so that's what I'm going to do. I am going to use the rsync technology inside of Openshift, and I'm going to show you that on the command line. The first thing I need to do is log in on the command line. So to get my login URL, I'm going to click on Command Line Tools, and here you can also download the command line tool for your operating system of choice. And I'm going to select this right here. And so what's important to know here, though, is this token, it is a password. You don't actually want to share this with anyone. It's just a token that you can authenticate to the platform. And I'm going to paste that right in. And now I'm authenticated to Openshift, and I am going to use the PHP demo project. And I'm going to look at his running containers. And he has 1 MySQL running containers, 2 builds that are not running. They've been completed. The reason they are still there is we always keep the builds around until you delete them, so you can look at logs or roll back to previous deployments. And I see he has a running PHP container here. So that's what I'm going to use. I'm going to say RHC rsync, my current directory, and I'm going to sync it to this PHP 5.6 deployment that he created here. 2G5, and I am going to send it to the opt app root source directory. So how did I find that out? It's very common in Openshift. If you're actually curious on how to find that, you can ask us afterwards, and I'll show it. And I'm going to hit enter here, and it just sent my changes over. If I go back to his app and refresh, we can see that we have a period. Now I can iterate quickly. I actually want exclamations just to make fun of him, like that. Click save, rsync, go back to my thing. That's my flow as a developer. Instant gratification inside of a container. I didn't have to run any builds, didn't have to do anything. But now that I've made these changes, I'm pretty happy with them. I got a database working, I got a great title that's making fun of his title. I'm going to create a pull request for him. And so what I'm going to do is I'm going to do a get status, and I see my index, and I'm going to change it, and oops, and I'm going to say fixed your title, and I'm going to push this to my repository that I forked from his. Okay, and now I'm going to go to my GitHub account, and I'm going to refresh this, and I can say this was changed 12 seconds ago, so that looks accurate. So let me make a pull request for Boris to actually accept. And there's my changes, and looks good. So I'm going to create a pull request and fix your title. I'm going to leave that. And I'm done. Fixed your code, Boris. You're welcome.
All right. Thank you, Grant. So you know what? So I came back to my PHP source app and github.com, and I can see that I have a pull request right in here. So fixed your title. So I'm going to take a look at it. In the real environment, so I'm going to go do a review. Actually, I shouldn't be the person because I'll be the person accepting and say, well, you know, okay, fine, it looks good. So I'm going to review this code. This is perfectly fine. And I forgot to hit submit. So that approves the code, and I'm going to merge the pull request in here. And I need to confirm it. So once I've done this, again, if we go back to the console, you will see that the new build would have started right away on the you can see it's running right now, right? So as soon as the build completes, the new application will get deployed. And after that application, the new version of the application gets deployed. You can see it happening now. If I'm going to go and refresh the web page, you will see that the changes that I accepted from Grant actually now becoming live. So the port is live, and I'm going to make it happen. So, so you see that the new port got created, and we're seeing the changes from Grant. Now I'm looking at it, and I'm looking at my team and saying, you know what, I messed it up. I actually don't like your change, so I'm going to roll it back. So how do you roll it back on the OpenShift? So I'm going to go back to the builds, and I know that the build prior to the one that we just did, it's actually the one I like. So I'm going to click on that. And it's in a deployment config, so I'm going to go in the deployment, and PHP 5.6, that's the web front end of our application. And the number 3 is the deployment that we actually, I'm gonna go roll back to. So there's a rollback button right here. And remember, you can do all of those things through the command line through a C tool, so we're just using web UI for the demo purposes. You can roll a number of parameters. I'm just going to use all defaults, and I'm going to go roll back that application. So what that rollback does, it created yet another deployment number 5. Because all the images are built, it's actually relatively fast to deploy new pod, and that new pod got updated. Again, going back to my application, and I can see that the title changed back to the 3 exclamation marks. So this is how you can work. I mean, this is a real environment of what the collaborative development environment would look like, and this is how you can make changes. So one other thing I want to do is actually, let's say it's holiday season starting, right? So one pod is actually a kind of crappy experience. We want to, like, everybody go and hit that website, so we're going to scale that application. So scaling is also relatively easy. So you're going to go and create 3 pods of that service, and you can see that of existing image, we're actually starting to deploy additional pods of that application. And now, if I'm going to go and refresh this, so what I'm going to do, I'm going to copy the URL of the application and start in private session. The reason I'm doing this is because my browser maintains the session, so always goes to the same session until I actually reset the cache. So what you're seeing here is I started in private session, I landed on a different container, right? You can see this from the IP address. So the other browser session hits 1.4, the one that I just created in browser, it hits 0.3.
And I must have hit 5.
The reason you hit 5 because we redeployed the app, and it used yet another node, which we haven't used before. Anyway, so this is just the illustration of how things are when you're scaling it. So they round robin across different nodes. Remember that diagram Grant was showing us, he was going through the concepts. So we have multiple nodes, and we're scaling the work across multiple nodes.
So I actually am pretty upset with you right now.
Are you?
Because you rolled back my change, and I think my change was better. So what I think we should do is do an A/B test and see which one's better.
Right. So show me how to do it.
Yeah, so I'm going to set this up, and we're going to let our users decide which app is better, and we're going to split traffic between the two. So let me go back to the Openshift console here. Let me go to our PHP demo project, and I can see Boris has his 3 pods, and we have a MySQL pod. So I'm going to create a new pod in here, and I'm going to use PHP 5.6, and I'm going to call this Grant is better. And I'm going to get my repo here. You can go to github.com/gshipley, and here's my repo that I forked. I'm going to copy that, paste this in, and click on Create. And so now, as you're familiar by now, what's happening is it's running a new source to image process, and it's going to download my source code, create a new Docker image, and it's going to deploy that out. And I am not going to hook a database up to mine. And then down here, we can see that Boris's is currently running. Let me make that a little smaller. So I'm going to look at the logs, and I'll explain what actually happens when you look at this log. We're actually pushing the different layers of the Docker image. That's one of the benefits of Docker, is that it uses layers. And so we're pushing each individual layer up to the registry. This will be done in just a second, and then we're going to set up an A/B split traffic route between the two. In this particular image, there's 10 layers, and mine is a brand new image. That's why mine's taking a little bit longer than when we saw Boris do his, because he was incrementally just changing this last layer. Because this is a brand new deployment with new source code, it's creating a brand new image for me. And so my app is deployed now, and it's going to be deployed, and I'm going to check mine out. Here it is, mine now. And so let's split traffic between these two. So I'm going to go to Application, Routes. I'm going to select the PHP 5.6 route. I'm going to edit this, and I'm going to say split traffic across multiple services. And Boris, I'm going to give him 50%, and I'm going to take 50% of the traffic. And we can see now that 50% of the traffic is going to come to this group of pods, and 50% is going to come to my group of pods. And if we go back to the overview page, we can see that the display here has changed as well, that 50% is going to go to these 3 pods, and 50% is going to go to this one pod. So let's test this out. Now, I have session affinity, so this is going to my one pod. Oh, that's the wrong URL, actually. This is the right one. Okay, so I am going to mine. So let me copy this, open up an incognito window, and paste it in, see if I get his. Nope. Try it again. This always works. So let me
start Internet Explorer since you're in Windows.
I don't like Microsoft that much yet.
All right.
Okay, you gotta give me
Break. All right,
Yeah.
we'll do. You don't like my change.
Okay, so there we go. I hit the same URL, and eventually I got his pod, right? So we are splitting traffic. And so this is how you would do A/B deployments to test a new feature out, gather some feedback, see if people stayed on your site longer or less, depending on the new version. And Boris, I hate to tell you that people actually enjoyed, after extensive research and study, they prefer my version. So can you actually roll back your rollback?
All right, I can roll back my rollback. So
All
let me
right.
show you how to do it. I'm back in the Openshift web UI, and I'm going to go to deployments of PHP 5.6, the web front end that I have. And again, remember that we had a new build, so the build number 4 was with grants changes. So I'm going to click on that and hit rollback on this guy. Again, hit rollback. So what you're going to see, the rollback started. So the new deployment got created. Now you will see the rolling upgrade of the application. So because we now have 3 pods, if I start hitting the website, you actually can see the intermediate state depending on which pod you're going to land, old or new. Now, as the old pods are scaling and the new got created, so the old one will disappear and all of the traffic will come to the new application. So now, because we're still routing between the two, so I might hit either yours or mine. So let me refresh that. So I hit yours right now.
Yeah, so let me clean that up.
Yeah, so why don't you
quick.
remove that from, so that we actually go into the database connected version.
So first thing I want to do is I'm going to scale yours up to 4 because we get more traffic now with my new feature, right? So then I'm going to go into the application routes. I'm going to go back to the route, and I am going to edit this again. And I am going to remove this service and click on Save and go back to the overview. And we are no longer splitting traffic anymore.
Right. So you can go refresh the site. You probably have it open somewhere. Right. So this should now have a database in the grants changes. Again, what you have seen in action right now is the kind of A/B testing you can easily do in the Openshift between 2 developers who are collaborating and deploying it. And again, this is from the point of view of person managing the infrastructure. So the people who maintain the Openshift cluster up and running, they don't even have to know the work we're doing as developers as far as integrating or working on a particular application. So we have about 15 minutes left of the session. And one other thing I think we should show is, do you want to show how to build the ASP.NET?
Yeah, do you guys want to see .NET on Openshift?
So one thing that we haven't done, so we're working with all Openshift things, and so there's a variety of things you can go and get from the GitHub to see how to deploy the .NET application, actually develop on C# on Openshift. And we'll have the link in the resources. So one thing that you should look into, just grab a deck and grab the links.
So what I'm going to do is I'm going to create a new app. And one of the things you can do on the command line is actually pass in one of these builder images. So we actually have a .NET builder image. This is going to be running on Rails 7. And I'm going to pass in some .NET source code. And I'm going to hit enter there. And this is going to do the same thing we've done all during the demo. It's going to download that image and build the source code. And it's going to deploy it. If I do OC get pods, we can actually see the .NET build happening. ASP.NET.
You can actually grab the log. So the OC, actually, what you see on the screen, OC provides the command line right for you, just to say OC logs-f ASP.NET. So you will get the build information stream, so you can run just that.
Yeah.
Come on, I'm learning now OpenShift better than you are.
I know, it's amazing.
I know, it's so easy.
Oh, except, there we go.
All right. So what you're going to see right now is the OpenShift, again, through the REST endpoint, is going to ship the logs back to the machine. So you will see what happens with the build itself, so you can track the progress of the build. So one other thing I want to show while the build is completing, it takes a minute or so. So go back to this GitHub repo. Again, we have that in the resources as a link. So this is the OpenShift source to image repo. It's a public repo where they just have ASP.NET example. And the 2 commands the grunt is running, they're right there in the README file. So you just run one command to the deploy application, and the second command the grunt is about to run is to expose the application so that you connect it from the outside.
So it looks like the compile has completed.
Yeah,
now it's going to create the Docker image and push it to the registry. So let's log into the console, and we can actually see what this looks like in the console as well. I should have an ASP.NET project here, and the build is running, and I can click on View Build, and this is the same view that I had on the command line tool. And it's pushing one of 4 layers. So this Docker image only has 4 layers, for example, right? As you build Docker images and say from another image and from another image, it adds additional layers. While it's finishing these last 2 layers, there's one thing I do want to show you. If I go back to my projects, and we go back to PHP, I don't believe we showed this. If I go down into a pod, I can actually open a terminal right inside of the web browser to actually access the pod. And so if I just wanted to come in here and view some log files or do some troubleshooting, I can do that inside of a container as well. So let's go back. It's now deploying this app. So let's wait for this to deploy. It's scaling it up to 1 pod. And then I'm going to create a route. And we should have a .NET application running. Oh, my zip.io died. Maybe you can show it real quick.
Okay, so let me try showing that on my machine.
Yeah.
So I'm going to go back to the console, and I need to refresh the list of the applications so that I see ASP.NET, and the route got created. So let me click on that. And again, using zip.io as a DNS, so we're connecting to NS. So we have a C#-based ASP.NET website running on Openshift inside of the container on top of the Microsoft Azure. So that's kind of the things you can do today with the OpenShift. So one other thing I want to point out is before we switch into the resources slide. So you can also hook up the Azure AD, as I mentioned at the beginning, because it supports OAuth authentication protocol, which is an industry standard. And it's simply the configuration change, that the change you can do yourself as you build your applications or as you build your cluster. So what you see in here is that I have another cluster that actually has it hooked up. And it's 003 as a name, so the same console. I'm going to hit enter on this. So what you'll see in here is actually it's taking me to the Microsoft-like looking web page and giving me identity I have in here. Because this is a Microsoft-hosted Azure AD and I used my Microsoft identity, you see one of the names I have in here is in my Microsoft address. So when I click on this, and again, we can describe in the lab or we can do it in Q&A. So I'm actually taking to the Microsoft Corp sign-in web page. So this is Microsoft-based authentication, Microsoft IT. I type my Microsoft password. I just need to make sure I type when I talk correctly. And because Microsoft forces us to use two-factor authentication, so it's going to send me the confirmation that it's indeed me. So even if Grant just saw my password, he has to hit me hard to get the phone and cut the finger off. So and after that, we can log in. So I received the authentication. I'm going to approve it. And what you will see as soon as it's approved, so my phone talked to Azure AD and said, yeah, it's OK to log in this user. I got the token, and I got the already application here. So this is another cluster. And as you can see in here, it uses my Microsoft identity. So I don't even have to manage that user. It's just the part of the Azure AD. So if your organization already have a bunch of users, and they are part of the Azure AD, and if somebody leaves, it's the matter of removing the Azure AD user from the directory, which is a standard procedure. And again, if you're going to go in here, that's yet another ASP.NET application.
And your zip is dead now.
And now my zip is dead. So what happens in here, because we hit this so often, especially in here, if you try it out today on the Wi-Fi in here, so what happens is the DNS gets reset, so the zip.io request actually doesn't come through. So if you go in settings and reset DNS to use automatic setting, it will start working right away. If you have your own domain name, by all means hook it up. Again, it's a configuration parameter in the application.json file, which you can set yourself. Then all of those problems go away. So it's just a matter of the fact that we're not using the custom DNS name. So with that, let's go back to our kind of the final slides of the presentation. So what we have in here, and you will have access to this deck with all the links. So as I mentioned, aka.ms OpenShift is the quick start template that we had. And what I personally recommend, and Grant may have a different opinion, so docsopenshift.com actually will show you all the docs for all the versions of OpenShift that would be online, dedicated, enterprise, or the container platform, or the origin. So depending on what you're working with, you can just pick the right branch and go there and explore how to deploy it and things like that. So the OpenShift source-to-image ASP.NET application, where you can write your own .NET website, is the third link. So we have the hands-on lab tomorrow at 2 o'clock. All of us and Harold, who will be helping run the lab, will be there if you actually want to try hands-on things like this on Azure. And if you have questions on Azure AD, how to deploy it, or any other specific questions, we'll be able to answer them then. On tomorrow as well, in the Partner Theater number 4, so Nicholas Gerasimatos from Red Hat will be presenting on OpenShift, and you can ask him questions about anything OpenShift. Again, it's tomorrow at 11:35 a.m. with Expo Theater number 4. You're welcome to stop by our booth, Red Hat or Microsoft, ask questions, or you can use our Twitter handles or the email addresses that are at the beginning of the deck. And I guess that's pretty much all I have.
The deploy?
Oh, so let's take a look at the deployment finished. So yes, the deployment finished, and what you see in here, at the end of the deployment, that's the author of the deployment defines what those things are. So, and the author of the deployment, actually Harold, who's going to be running the lab, it gave me the URL that says this is the URL of the OpenShift console. So I'm just going to grab that URL. It also gives me the public IP of the nodes themselves, and the SSH command if I actually want to go get into the machine. So minimizing this, reusing this window, and I'm going to hit enter, and I should be able to log in into console. Because we're using self-signed certs, it warns me that the certificate is not available, and here we are. I'm at the login page of my OpenShift cluster, and the rest is the same. So this is 1005.
Awesome.
So it took us, what, 20, 25 minutes? I don't know. We probably run longer, but 25 minutes approximately, that's how much it takes to deploy a cluster like this. Anything else, Grant?
No, that's it. We'll be sticking around. If you guys
All
have
right.
questions, just come on.
Thank you for coming, and we open for questions. So we are 4 minutes before the session ends.
Oh,
Thank you.
okay.
Any questions? Anybody runs OpenShift? Yes, go ahead. If you want to ask publicly, you can do so, or you can stop by.
Yeah, so when Grant made the change and to the container that you deployed,
Mhm.
he actually did not redeploy the container. He just changed the existing container, right?
Yes.
Second question. In the OpenShift UI, today you cannot create volumes and attach volumes to a persistent database.
You can now.
Now,
Yeah.
OpenShift 3.3,
Yes, as of last week, and I can show you real quick. So now you can come into storage and click on request storage. We don't actually have persistent volume set up. Oh, maybe we do. My storage. I don't know if this is going to work or not, and maybe we want, 1 gigs of storage. And click on create, and it's going to create that for me.
And again, what we've done is OpenShift 3.3 came out on Thursday last week, and literally yesterday so with a couple of other clusters we have there 3.2, and we were kind of looking for, we should probably get the latest and greatest cluster, so that's what OpenShift Origin is for. Right, so just if you want to play with the features like this, definitely go with the Origin. If you want stability sort of certification process and support for your OpenShift, you will go probably OpenShift, Red Hat OpenShift Enterprise or Container Platform.
so the resource template that you have today on GitHub is for OpenShift.
Origin, yes, yes,
Correct.
yes. And one thing I will point out. This is kind of interesting. If you have not looked into templates themselves, so I'm going to open back my quick start templates. The few files mentioned in here. So one of them is deploy OpenShift.sh. That's the script we're calling from the VM. And this script, actually what it does, it configures the hosts right here. So that's the configuration, and you can see that the couple of lines that we edit, and we'll probably do the pull request for the repo to actually put them out, this is what references and makes it OpenShift 3.3, just a particular release tag. And then, so the other question.
Well, Harold has created a script for Enterprise as well, OpenShift
Yes.
Enterprise.
So we don't have it in quick start templates, but if you actually go into his repo, the reason for the enterprise being more complex, you need to register a machine with the Red Hat entitlement, which means you need to pass additional parameters like a username and password that could be used on the VM to actually register additional repos. And I guess what I'm trying to point out, if you feel that you want to add Azure AD in here, so what you see in here is that the Azure OpenShift master identity provider is this HTTP auth. This is the simple username and password. I can put Azure AD parameters in the tenant ID and the application ID. That's what would make it connect to Azure AD. Again, this is not hard, but this is just the configuration parameters. Similarly, we're using the generic base URLs. This is what zip.io, where zip.io is used. If you have your custom domain name, which you want to play with, definitely put it in here and deploy from the local file. That's all simple, 25, 28 minutes after all config changes, should have your cluster up and running.
I'll update this so that it
Right. So again, what Harold is mentioning, so Harold has a couple of private repos, so he was authoring the quick start. In his repos, if you referenced in the history of that quick start template, you will see reference to his repos. He has enterprise in actually a couple of varieties. But the point is, you should configure it to whatever your environment is. So if you're playing with the enterprise all the time, just use one of those and just tweak the way you want it and work with a local file or with your own repo. One word of warning, people do it all the time, do not check in local parameters, please. Like local parameters, like the passwords and the private keys and all those things. It's amazing how often people do this, and it's actually amazing how fast various scanners pick them up so that your infra gets compromised really, really fast. Kind of, we actually working, this is a side note completely, with GitHub to track those, because GitHub has access when you check in to look for things like this, like passwords. And it can say, you checking in something that looks like password. Do you really want to do it? So anyway, that's a side note digression.
Next question?
In the future,
Yep.
do you plan to open up the URL that you have, the GitHub URL, to Visual Studio to team services, so that the DevOps, when the code change happens, today you have a webhook which interacts with GitHub, but
So-
not with Visual Studio team services. So in the future, do you plan to
Yeah, so we have two different webhooks, actually. Whose screen's up?
It's mine. Yeah, you can.
Let me
you can
switch to mine real quick. So if I go into builds, and go into this build and look at the configuration, we have one specific for GitHub, but we have a generic webhook as well that should work with any platform. So I personally use GitLab, or that's what I use. So I use the generic webhook and not the GitHub specific one. Yeah, so we do support any revision control system. So. Any other questions? Yeah.
So if we deploy Openshift, what is a developer and what is an operations person need to know about Kubernetes?
So OpenShift is Kubernetes. You can think of it as an enterprise distribution of Kubernetes. So you can interact with it with the kubectl command line tool. What do they actually need to know? Little to nothing. No,
For
not
deployment,
really.
actually don't. You
Yeah.
don't even know that you're doing it.
Yeah.
So you call Ansible script that deploys the rest, and you don't even see the guts. For the developer, I guess, even though
I mean, they need to know what a
Height.
pod is,
Yeah.
because that's like a basic. Yeah, just
Yeah.
terminology. Yeah. No,
right.
that's the goal, right? Is just to use it. So. Yep.
It would be nice if you put out a demo as a YouTube video.
We probably should. I mean, we'll.
Yeah, maybe we will.
Actually,
We met on Monday of this
Yeah.
week, so.
It's really cool.
Yeah.
all right. So we'll think about it. Channel 9 or YouTube. Yeah, Microsoft YouTube. Yeah, it's a screencast is recorded, but we should probably do more fun with Rick and Microsoft Mechanics show. I mean, you're free to, everything you saw is all in the public GitHub repos, and again, you can just go and play with it. It's one thing I would say, with people here is lots of deployments issues, and kind of, if you really want to have a cluster up and running before you leave the conference, just stop by tomorrow, we'll deploy one. It's literally taking maybe 20 minutes with the key creation, depending on if you're using Windows, Mac, or Linux, because different tooling needs to be installed. If you have Windows 10, you can use bash script to generate the key right on the spot, and then push it into Key Vault. That's all it takes. I didn't go through this because I already have the key created before, but after that, you can go start and stop the cluster. So starting and stopping, there are, again, those things you will learn as you go. We're using in the template the static IPs, which means if you stop the VMs and you come back up, the internal IPs might change, but the external will always be the same, which means it's OK to stop and start. We haven't really done that overnight. We decided to keep the cluster up and running. We can try to actually see if that comes up. There might be, like, as we were debugging this, we found some interesting, as I said, OpenShift origin is the bleeding edge. We were creating the MySQL container, and we were just typing MySQL everywhere. And apparently, well, not apparently, MySQL is a reserved database name. So if you try to spin up the container MySQL with the MySQL database name, it will fail. And it actually was a kind of things that you might run into subtleties like this that are not necessarily caught in the
Yeah.
UIs.
I mean, I've written 2 books on OpenShift, and we found this out today, actually.
Today, yes.
And I filed a bug on, like, we should tell people that, but yeah.
like you will run into things like this, and they might be very, very easy. And if you done, like we've done enough of deployments to answer, oh, you just do this, and that will be quickly fixed on the spot.
Can you talk about customers using OpenShift today?
So unfortunately, we do not have public referenceable customers. So we have a couple of customers who are using OpenShift in Azure, and they providing the services to third parties. So this is a equivalent of hosted services. Again, the company has not agreed to share the public information on them,
Yeah.
but there are people who run OpenShift and basically provide the services. They host websites for other people. You saw how quickly it is to build a website, so you can effectively resell the services of the OpenShift as the platform, as a PaaS platform to a third party.
So moving forward, is OpenShift planning to change their public OpenShift gear mechanism to Docker-based, or is it going to be gears?
We've already launched it in a developer preview. You can sign up today and get an account on it. So if you go to openshift.com and click on sign up, you can log in with GitHub and get access to OpenShift 3 in a public cloud. We accept a couple thousand people a week, so you just have to wait your turn to get in. But yeah.
But it is Docker-based now.
It is 100% Docker-based. We shut down registrations for the gear-based one.
So moving forward, does OpenShift plan to support any other orchestration clustering like Swarm or Mesos?
So the question is, in the future, does OpenShift plan to support any other orchestration frameworks such as Swarm or Mesos? Right now, we are fully committed to Kubernetes. We made that bet several years ago, and we're the second largest contributor to Kubernetes. So I'm not going to say never, because things change rapidly. But right now, I don't know of any plans for us to rip out Kubernetes and put in Mesos, for example.
What's your plan for Windows Server Container?
I know absolutely nothing about Windows Server Container support.
Maybe that's the start of the conversation.
Yeah.
We should have. So
Yeah.
we convinced him to come with a Windows machine, so that's the start.
I know there is work going on Windows Container support for Kubernetes.
Yeah, yeah. I mean, really, the only thing we need to run is Kubernetes. So if Kubernetes is running on Windows Server and it supports Docker, then we should be able to be a schedulable node for us.
All right. Thank you. Thanks again.
All right, thanks, guys.